Okay, good evening everybody. Welcome to second revision session for quiz 2. Just like the previous quiz session, the revision sessions, we will be discussing the mock questions. But before that, if anybody has some doubts, right? Go ahead.
Yes, ma'am. I have doubt in graded assignment week 6.
Okay. Can you share your screen?
Yes, of course. Ma'am, you can open also yours from your side.
Okay. You want me to share? Okay, fine.
Hmm.
Okay. Where you have the doubt?
Question number 14.
Week 6, right?
Mm-hmm. Can you please explain the question, ma'am? Little bit.
Which one? Which question? Just let
Uh,
graded assignment.
the week 6 GA graded assignment
Yeah.
number 14.
Number 14.
Hmm.
Okay. Okay. What is the doubt here?
Ma'am, can you please explain the question? Means, choosing the option. Going little bit tricky.
So you have a priority queue. You know what a priority queue is, right? In a queue, for every element, you have some priority value. Okay, what is your ID value or something? So higher is the number, higher is the priority. Like 1 has low priority, 10 has the highest priority. So if a number is having the priority 10, it is the highest priority. So when you are dequeuing the operation, you will remove the element with the highest priority from this queue. Okay. So here you are asked to write the function for the delete max operation. So what is the delete max operation is this is using a sorted list, right? So you are having a list. You don't have a sequence of numbers in a list, and then you have to just uh, remove it. This is a sorted list. Okay. So the elements are sorted according to the priority queue, and here it is asking that you have to perform the delete max operation, which is basically the DQ operation. In the DQ operation, you have to find the element with the highest priority and then you remove that element, right? So the delete max operation here is basically performing the same thing, which is basically it will delete the element from the priority queue, but because it is a priority queue, you are deleting the maximum element, which is basically same as the DQ operation. Okay, so you have to perform the DQ operation over here, or delete max operation, which is basically you have to remove the element or delete the element from the queue, which is the highest priority. That's the question. What exactly is your doubt here?
Ma'am, while choosing the options,
Okay.
I'm getting confused between option. Let me check.
If self dot queue of Okay, so here it is basically these options are in this for loop. It's varying over here, right? Between the options, the only difference is coming over this particular portion and computing the largest value. What this for loop is doing. So what is for loop is doing? It is finding the element with the largest priority. Okay. So here in this for loop, it is just doing that q of I is greater than q of largest. Then you do largest equals to I plus 1 and stuff like that. Okay. So here this is basically this for loop is involved in finding the element which has the highest priority so that you will be deleting that particular element, right?
Mm-hmm.
So this is basically that part. So here, if you look into the other options, all the options are varying in this portion only. on how this for loop is designed. So you
Hmm.
have to like you have the largest you have a variable largest which will store the maximum element or maximum value or whatever it is. It will store that particular value and you have to find the code to for which will do that. Okay.
Hmm.
So
So
now
so
basically you have to find the one with the largest value, the code which gives you the largest value stored in the largest. That's it.
so why option C is correct? Then option A is also correct, na?
Option A is not correct, right? Your largest will be equal to I plus 1. Why will largest be equal to I plus 1? If you are checking the ith element, you are checking that the ith element is greater than largest, but you are storing the I plus 1 at location. That is not
Oh.
right, right?
Oh, got it, got it, got it.
Okay.
Hmm. Now, ma'am, week 7, question 6.
Okay.
GA.
Week 7, GA,
Question 6, I guess. Let me check.
question number 6. Yeah. This one.
Yeah. Ma'am, how we will sort the IDs here? I mean, in which order we should choose?
based on due date.
Hmm? Here saying that after continuous 5 hours walking, the machine can take a rest for 1 hour. That's it bit confusing.
Before completion of
Hmm?
has to rest for an hour mandatorily after every 5 hours of continuous work. But the machine can take rest for an hour before completion of 5 hours and become available for. Okay, see, here it is the rest time is uniform for all the machines, right? See, this 1 hour rest is uniform for all of the machines, right? Hello?
Yes, ma'am.
Yeah, so this 1 hour rest time is uniform for all of the machines. So whether that machines take hour rest before or after this 5 hours, it will be same thing only, right? See,
Ah.
here it is 5 hours of work in this 10 hours. If it is due in 10 hours, it will take it will at least work. It will like work for 5 hours, then six plus one will be there or
Hmm.
it will either take one plus then it will do the 5 hours. It doesn't matter. But overall, this entire timing will be six for all of them, right? So whether you
Hmm.
take this 1 hour rest before or after into account, that doesn't matter. You can do it either way.
Hmm.
Is it not get you? Are you not getting the correct answer?
Yes, I'm getting, but which I should choose? Like, I means
See,
5 hour,
for
5 hour
this
time required.
particular For this particular question, this rest hour of 1 hour is uniform across all the machines, so it doesn't matter whether you take before or after.
So I will choose two IDs. Which combination should match the time required is 5, not more than that or not less than that, I think.
Sorry,
Hmm?
sorry.
मतलब मैं वो दोनों आईडी चूज करूंगा जिसका रिक्वायर्ड टाइम का सम 5 आएगा, उससे कम ज्यादा नहीं होना चाहिए, ऐसा कि उससे ज्यादा नहीं होना चाहिए, कम होगा तो
Yeah, do it accordingly only. The normal process. Just that I'm saying that if for this hour, if you're getting confused about the hour, then
हम्म
you should not. You just use it as an extra hour. Whether it is taking before or after, it doesn't matter.
हम्म
Make sense?
so when I am choose two jobs, then I please scroll down,
Mhm.
and then I will choose like 4 plus 1 mean 1 and 2 and then 0 and 3 like that.
4.
4 and 1 and then 0 and 3 like this way.
4 and 1, you are saying from here, and then 0 and 3, you are saying from here.
Hmm.
See, here it is saying that you should sort the job in increasing order of due time. You can just sort according to the increasing order of this due time also. That will be also be fine. Because the lateness will be zero anyways, and then here you can just include the lateness whenever after the 5 hours. When it is starting, the start time is 5 hours. No, so
Hmm.
here you can just include for 1 hour. The extra 1 hour can come over here. This is also correct method only. You can follow this way also.
Mm, this bit confusing. Like,
What is okay? See here, start time is 1 hour. Sorry, one, and finish time is two. So there will be no issue. This is clear, right? This is clean for job ID one. Then coming to you sort according to this due time. Okay, for job ID one, two is the deadline, and it is starting at one.
hmm.
Okay. Because the time required is 1, so the start time will be equal to 1. You have to calculate the start time. This is the total time required. Okay. So, hello.
Yes, ma'am.
Why is the start time 10 here? Oh, okay, okay. It is what it is saying that you are
Reverse.
sorting it. Okay, you have
Mm-hmm.
sorted it. So this job ID 1 started at 1 and finished at 2. So job ID 3 has to start at 2 and finish at. It takes 1 hour. Job ID, which one? Job ID 3 takes 3 hours. So it starts at 2. So the finish time will be 5, right?
Hmm.
Ma'am, but where the start
And
time is 1.
yeah, yeah, it should not be 1, right? No? Machine has to rest for an hour. But the machine
Ma'am,
can take
here we are
rest.
given two choices, right? So based on
Okay.
the choices, it will differ.
Sorry?
Here we are given two choices. Like machine can directly run for 5 hours, and then it has to stop for say 1 hour, and then again it will start, right? Or another thing is before 5 hours, right? Before completing the 5 hours. If the finish time is before completing the 5 hours, then there will be no lateness. So that was one of the question which was asked earlier also in one of the sessions.
See, let's say we are starting at point 1. Okay, start time is 1.
Hmm.
And we are starting with job ID 1. Then we will have like finish time will be 2. So lateness will be 0. Okay.
Yes.
Hmm.
Now for job ID 3, if we can only start at time 2. Start time will be 2, but finish time cannot be 4. Finish time will be 3 plus 2, that is 5. Okay. So 5 hours it will be fine, right? So it can have a lateness of 0. This will be 5. I think this is a typo. Okay. Then for
Yes,
one
there is
hour
a
it
type.
will uh, take a rest.
Ma'am, the question is a bit confusing actually.
Seems like it. Yeah.
Hmm. The question is a bit confusing
The
and
solution is not clear.
solution also not clear. And in our graded assignment, solution is not even given. In your assignment, I think you are instructed that
Yes.
it is given. In our case, the solution even not given.
Yeah, I logged in via the admin, no? So that's why I can say not the
Okay.
solution.
But again, the solution is wrong. It's like not wrong, but I think there are typos in this one.
There is a
Uh,
typo, I think.
because the
Okay,
concept is not
let's
getting clear.
try to solve this. Let's try to solve this. Okay, so we are starting at time point 1. Okay, at time point 1 we are starting, and job ID 1 is taking 1 units of time. So we are done at time point 2. Okay, this is ID is 1, job 1. Okay, at time point 2, this is done. Then we are going to job number 3, which is taking 3 units, which is basically 2 plus 3 is 5. 3 will be done. Okay, due
Mm-hmm.
is 7, but we are doing at 5. Okay, we are due by 7th hour, but we are due by 7th hour, but we are done by 5th hour. So our lateness is 0. Okay,
Zero here. Huh? Oh, okay.
yeah. Then then we are going to the second job, but now we want a break here. So until 6, we cannot do anything. Machine will be, this is the break period. Okay. So now from here, we will go for 4 hours for this job number 2, which is basically 10. Okay. Hello.
Why not 8?
Why do you want to? The time required is 4 hours, right? From 6 to,
Mm-hmm.
if you're starting job number 2 here, then you
Mm-hmm.
will have to run the machine for 4 hours, no?
Mm-hmm.
Okay, so you at job num at time of time point 6, you're starting the okay. At time point 2, at time point 6, you're starting job ID number 2, which requires 4 hours. So your machine will run for another 4 hours. Okay,
Okay,
so
okay,
that
yes, yes.
would,
That's due time. Mm-hmm. Understood.
yeah. So 10 is the time. So lateness for 2, which job ID 2 will be equal to 10 minus
2.
8 is 2. Okay, then we have, which one is remaining? This job is remaining for 2 hours, but if we take a 2 hour over here, if we take 2 hours, then it will go to 12 and we will have the machine cannot work. It will need a break in between. So we will take a break over here and then we will start this is the break period of 1 hour. Okay, we will take a break over here and then we will start the machine's the job ID 0. Okay. So then we run the job ID 0. Hello.
Yes, ma'am.
Mm-hmm.
To 13. Okay. Job ID 0 will take a time required of 2. So 11 plus 2 is 13. So we are going to, this is job ID 0. Okay. So 2 hours we are going. And this is now at time point 13. Our job ID 0 is getting over. So 13 minus 10. So the lateness for this is 3. So total lateness is 5. Okay. Hello.
Yes, sir. Yes, ma'am. Sorry.
Okay.
Oh no,
Jane.
ma'am. I think total lateness is 3.
Sorry.
Total lateness is 3. I think the answer is 3.
Answer is 3.
Hmm.
How did they get this answer?
You
Okay.
have to
Give me
start
one
the
minute.
start
I
time
will
as zero.
connect. Sorry.
You have to get the start time from zero.
If we start time at 0,
Yes,
Yeah.
start time will be from 0.
if we use the start time equals to 0, then what will happen?
Things will change.
Yeah, it will change. But how? Let's
The
see
extra
what
2 hours
happens.
will be reduced because we will
Hmm.
finish within I think
This
the
is 0, 1,
zero.
and 1 plus 3 will be 4. So this will be 5. Okay. Yeah. This is how it is coming. The start time here was supposed to be 0, I think. Start time was 5. 5 plus 4 hours, that will give us 9. Then 9 plus take rest for 1 hour, which is 10. Then we have 2 hours, which gives us to 12. Okay, so then the lateness will become uh, 1 plus 2 equals to 3. Okay, If you start from time point 0, then it is coming as 3. Hello?
Yes,
Yes,
Am
ma'am.
I
ma'am.
audible? Am I
Yes,
audible? Hello?
yes, ma'am. You are
Yeah.
audible.
Okay, so give me 5 minutes. I need to change my earphones and just give me
Okay,
5 minutes,
okay,
okay?
Hmm.
I'll connect to a different earphone. Hello, can someone confirm if I'm audible?
yes, ma'am.
Okay, great.
It's low voice.
Yeah. I was just fixing it. What about now?
Clear, clear,
Sorry?
clear, ma'am. But echo. Now
Hello?
clear. Yes, ma'am. Clear.
Okay, great. Okay, this one is clear, right? This problem?
Hmm. 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 Ma'am, I want to share my screen.
Okay, wait. Let me stop sharing. Yeah, go ahead.
This question.
Uh, Let W be the minimum weight among all edge weights in an undirected connected graph G. Let E be a specific edge of weight W. Which of the following statements is true? Okay, okay. What is your doubt here?
Ma'am, the correct answer of this question is there is a minimum spanning tree containing edge 3, edge E.
Yeah.
But it is not necessarily, because if your minimum edge weight is W, so the minimum cost spanning tree always contain the edge W. Why E?
Uh, sorry. Can you repeat? Sorry.
It is saying that W be the minimum weight among all edges in an undirected connected graph G. Let E be a specific edge of weight W. Which of the
Yes.
following statements are true? So
Yes.
when W is the minimum edge weight, then
Yeah.
there is a minimum spanning tree that should contain W, not E, na?
Yes. Agreed.
So why should it is showing
Let E is a let E is VSP is.
hmm, this these two options are
E
correct.
E is the edge with the weight W.
See, it is not saying that every minimum spanning tree should contain the edge E. It is saying that there is some minimum spanning tree that contains the edge E. That is where you're getting confused. Okay.
Hmm.
uh, what it means is, if you it would have said that every minimum spanning tree should contain the edge E, then I agree that no, that is not the case, because there will be at least one of the minimum spanning tree which does not contain the edge E. Let's say there is a let's say W equals to 2, so there are two edges in the tree between two edges in the tree where you are having a weight of 2 or something like that. Okay, so one of them will be in one tree and the other two will be in another tree. That is possible, that is allowed. Okay, but what it is saying is there is some minimum spanning tree which contains the edge E. So what it means is there is one particular minimum, there will be some one minimum tree or two minimum trees or whatever, but at least one minimum tree will one minimum spanning tree will contain the edge E. That is the true
Oh,
statement.
that's why this option wrong. Every it is saying every.
Yes, yes.
And this is not it, this is saying that ये कोई भी स्पैनिंग ट्री में नहीं रहेगा, ये तो गलत है सीधा, और ये एवरी के लिए गलत है। अच्छा, ये ऑप्शन भी क्या कह रहा है? इफ एज ई इज नॉट प्रेजेंट इन द मिनिमम स्पैनिंग ट्री, देन इन द साइकिल फॉर्म बाय एडिंग एज ई टू टी, all edges have the same weight w.
Okay, so what
This question, then in the cycle, formed by adding age e to t. What does it mean?
what it means is, let's say you have a minimum spanning tree. Okay, then what you are doing is you are just for fun you are adding the edge E to this tree. Okay,
Hmm.
now it will no longer be a tree, it will
Hmm.
no longer be a tree, it will be a graph, but it will no longer be a tree. And why it will not be a tree? There will be a cycle formed due to this edge E. When you are adding an extra edge to this spanning
Hmm.
tree, then it will form a cycle,
Hmm.
right? So
Hmm.
now in this cycle, what it is saying is, in this particular cycle, every edge in this cycle will have the weight W.
Hmm.
Is this true or not? That is the question. Get it?
Hmm. It may be true or may not be,
No,
because
it will be true. These are properties of minimum spanning tree. You can search online, you will find the proof to this also. So why it will be true is, the idea is, if you see between every pair, because W is the let's say the edge E is connected between some X and Y nodes. Okay, so
hmm.
if you are adding this edge E, then there is the weight of uh, let's say between X and Y node, the edge that is existing in the minimum spanning tree was having some weight, let's say W plus 1 or something. Okay,
Hmm.
but if now you are having another shortcut path from X to Y, which is having a weight of W, so W should have been in the tree instead of W plus 1, right? Because
Hmm.
W is the minimum weight, no, among all of the edge weights. Then that's why it will be true. You can look online, you'll find the exact proof for
All
this.
edges have the same weight w. Then
All edges in that particular cycle will have the weight W. That's what it is saying. In that cycle that will be formed when you add this edge E to the tree. Get it?
hmm.
Draw a triangle. Draw a triangle somehow.
Hmm. Then
Yeah, draw a triangle. So for A to let's say number this A B C. Okay,
hmm. A
let's
B
say
C.
BC is equal to E. The E edge that we are talking about is BC. Okay,
Hmm.
and your minimum spanning tree is formed by AB and AC.
Hmm.
AB and AC is your minimum spanning tree.
Yes,
Okay.
node minus one. The edges are two edges.
Yeah, that is your minimum spanning tree. Now what you are doing is you are adding the edge E. E is your BC, so now you are adding E to the minimum spanning tree. So you get again the same triangle, right? But in this triangle, this is also a cycle that is forming in your minimum spanning tree. Your minimum spanning tree was only AP and AC.
Hmm.
Now BC is being added, so this is forming a cycle in your minimum spanning tree. Okay,
Hmm.
so now in this cycle, suppose let's say AC was having a weight of W plus 1. W, let's say W was 2
Hmm.
and AC is now having a weight of 3. Then if it was a minimum spanning cycle, then how come you ignored the weight with 2 and you added a weight with 3? You get it?
No, no, not getting it, ma'am. Can you please draw, take a screenshot of this and draw in your
No,
notebook?
not required, not required. You can just close this.
thing and I'll share my screen.
Okay, okay.
I'll stop sharing and
Ma'am, I have a small question.
yeah.
Means will you be covering any topics or we will be solving this PYQ only?
No covering topics after this doubt.
Sorry?
Ma'am, you covered the topic of week 7 and 8 now.
The plan is we will be discussing if you are having any doubts, and we will be discussing the mock questions.
Yeah, okay,
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 okay.
okay. That's good.
Actually, ma'am, most of the complicated mock question has already been solved, I think. Is it Pushpendu?
No, the later weeks, right? Week 7 to 8, those that was not solved.
Hmm. But,
Sir only solved
but
5 to
most
6.
of the statement-based questions are solved, I think.
Yes, they are almost similar to the
Hmm.
earlier PYQs and GS and PS, so
And
you
the
can
left,
say solve that.
the ones that are left is quite easy, I think. Oh, I
Um,
also solved it. Hmm.
I think two are hard, means not hard, it's medium, but rest of them are quite easy. Yeah, those are just theoretical questions, so you can easily
Hmm.
do that.
Ma'am, then you can you please draw the triangle?
Yeah, yeah, yeah. I'm coming to that. 1 minute. Okay. See here. Let's say we have a triangle. Okay. This is A. This is B. This is C. And BC is the edge E with the weight W. Okay. Hello. Hello.
Yes,
Hello.
ma'am.
Yes, ma'am. Yes, ma'am.
Okay, great. So let's say BC is the edge E with the weight W. Okay,
Hmm.
and your minimum spanning tree does not contain this edge, right? So what is your minimum spanning tree? Minimum spanning tree looks like this.
AB and AC.
Yeah, this is AB and this is AC. Okay, so let's say this is having a weight of W1 and this is having a weight of W2. Okay, so now what we are going to do is uh, for fun, because we have nothing else to do, we will add this edge BC. Okay, and now BC is having a weight of W, right?
Hmm.
Okay, so now the claim is, what are they claiming? The claim is that this W1 W2 is equal to W, right? So when you are adding this edge BC, notice that you formed a cycle. Earlier it was a tree. When you didn't have this BC, it was a tree, right? Now you are adding this BC, so it will become a cycle.
Yeah. So the property has been violated of spanning tree.
The property has been violated for the MST. Okay.
Hmm. Hmm.
So now what we want to say is the claim is that W1 and W2 are equal to W, right? So now let's say that W1 is not equal to W. Okay, for let's say that W1 is not equal to W, right? So what can be the possible values of how exactly W1 and W will be related? See the first statement, it is saying that W is the minimum edge in the minimum W1, sorry, W is the minimum weight of all the edges, right?
Hmm.
So W is like the minimum value out of W1, W2, W,
Hmm.
right? And we are claiming that W1 is, we are assuming that W1 is not equal to W,
Hmm.
right? So our W1 will be greater than W. You agree to this?
Ma'am,
Hmm.
I have a
Hmm.
doubt.
Hmm. Minimum cost spanning tree, na? Then
Yes.
um,
then
W1.
W1 should not have been chosen over W. You agree?
Hmm.
Yes.
If this condition happen, if W1 is less than W, then we can grant it. But if W1 is greater than, then it
But
should.
W1 cannot be less than W, right? W1
Because,
cannot be less than W. W1 less than is W is not allowed. W is your minimum value of the weights.
hmm.
So how can your W1 be less than W? You
Hmm.
took W1, W2 and W and you found the minimum, and you are saying out of these three values W is the minimum, and
Hmm.
then you are saying W1 is less than W. Is it possible?
No.
No. So W1 is not less than W. W1 cannot be greater than W. If W1 is greater than W, then you should have chosen W over W1. This is the minimum spanning tree, so you should have chosen W over W1. You cannot choose W1 when W is also available to you, right?
Yes,
Hello?
ma'am. Yes, ma'am.
Yeah. So under that scenario, this is also not available. This is also not possible. So the only option that is possible is W1 will be equal to W. This is the only option which is possible.
So all age weights will be same.
Sorry?
So then all age weight will be equal to W.
Exactly. All edges
Hmm.
will be equal to W. Okay.
Hmm.
These are basic properties of minimum spanning tree that you can find online. All of these
Hmm.
proofs. Okay. These are just simple proofs, but you can find online. Okay. The same thing for W2 also. If you take W2 instead of W1 and do the same thing, no, you will also get W2 will be equal to W. So if suppose instead of this triangle you are having a square, try for a square. I will not do for a square. You can go ahead and try for a square. You will get the exact same thing. In the minimum spanning tree, what will happen? You will have three edges, right, and one of them will not be there. So when you will be adding the fourth edge, you take each one of them, w1 w2, take w1 w2 and w3. This is w. Okay, and then you compare, take w1 and w. If what happens if w1 is greater than w, what happens if w1 is less than w, and so the alternate will be w1 will has to be equal to w. Okay, try to do this. Got it? Hello?
Yes, ma'am. Got it.
Okay. Great. What
Ma'am,
else?
yes. You can address some good questions also if someone have any good questions.
Excuse me? What?
If someone have any good means some quality tricky questions, then you can ask them also.
Ask them what to share their questions.
Mm-hmm. Because mock test is quite bit already been solved.
Mock test already solved. All the questions have been
No,
solved.
no, not most of
Not
the
all, ma'am.
tricky questions.
Which questions have been solved from mock test?
Ma'am,
Actually,
only
what
week.
happened? Uh,
Sorry?
Sir actually solved all the means like all the questions which were from the concept of week 5 to 6. He solved all the questions actually.
Yeah, but I have to solve the
Week
mock
7,
test.
8 are pending.
Okay. Week
Yeah,
7
I
and
get
8 is left.
yeah, I
Those are
get
easy
that. But
actually.
the thing is, I have to solve the mock test questions. That's like in the schedule. So I have to do that.
Okay, okay, no
Apart
problem.
from that, if you have anything else to do, then we can look into that. Okay. So the thing is, let's just start with this mock test. Let's finish this up. And then only easy questions are remaining, you are saying. So let's just finish the easy questions and then we will see if you have any other questions to
We
discuss.
can
Okay.
try solving one of the PYQs. It will be easy, right?
That's I am also thinking.
Yeah, we can do that, but we will have to solve this mock 2 first.
Yes,
Okay.
yes. Okay, no problem. You can continue.
Yeah, okay.
Man, can you just hide that banner? This meet.google.com. That is there.
Okay. This question is solved?
Yeah, ma'am.
Yeah, I'll just scroll one by one. Tell me which questions have not been solved. So I will start from there. Okay. This is solved?
This also solved. Solved.
Solved,
Solved.
solved,
Solved.
solved,
Solved.
solved, solved.
Solved. From 8.
Hmm.
From here?
No. Hmm.
Okay. Okay, so a priority queue is implemented as a maxip. Initially, the maxip is 20, 18, 15, 13, and 12. Two new elements, 10 and 17, are inserted in the given maxip in that order. What is the maxip after the insertion of the element is dash. Go ahead. What should be the solution? Hello? Hello?
Yes, ma'am.
Option 4.
Yes, ma'am. Fourth option.
Option 4. Oh, yeah, I'm not asking which option. I'm asking explain why option 4.
Ma'am,
We can create the
first
heap.
insert 10, first insert 10, and then check, do you need to step up? If necessary, then you can do. Otherwise, remain it as it is. And then insert 17.
Hmm.
If need to step up and adjust for maxip, then you can do that. After doing all the operations, your answer is coming as option D. I have already
Okay,
found.
okay. So, do you want me to draw the maxip and explain what he said, or is it
Ma'am,
clear?
one thing I want to know is from the list without drawing the graph.
Okay.
From the list, how can we find the answer?
See,
Just by through the list.
see. From the list, the algorithm is indeed finding from the list itself without drawing the graph. Okay, I agree to that. The algorithm, the computer is doing that. And if you solve the algorithm, if you go along the algorithm one by one, the step by step, then you will be able to solve directly from the list without even drawing the graph. Okay, but there is a reason why we are taught about the graph, because that graph gives us a visualization thing. The computer cannot use a visualization thing. Computer follows a step by step process. Okay, so if you want to if you want to solve without the graph, then you follow the step by step process. But otherwise, you just, if you want to have a visualization of how this maxim exactly looks like and what is happening to understand that, then you should go for the graph. But
Okay. Because graph one I can easily understand. Just using the list, we have to do a calculation, right?
yeah, just use the proper step-by-step algorithm. No, the algorithms given to you, the pseudocode is given to you. Just use the pseudocode. Just use the step-by-step process of the pseudocode.
Okay.
Think you are the computer and try to solve on this particular problem and construct the maxip, and then this is the maxip given to you. Then you insert these two elements into this. Use that algorithm step by step, and you insert these two elements, and then see what happens. You'll get the exact same thing. Okay,
Okay.
getting what I'm saying?
Yes, basically use that equations which are given to us, right? That 2 into I plus 1 and 2 into I plus 2.
Yes, exactly.
Right?
Those equations and the formulas that you have, the pseudocode that you have, you use the pseudocode and then you solve it.
Okay.
पुण्यंदु 7 का आंसर 31 था ना?
Seventh one, yes, huh? 31.
Okay, so do you want me to draw the graph for this? We can actually draw the graph for this. This is 20, there is 18, 15, 13 and 12. This is the maxip initially, right? So now
Yes.
where will 10 be inserted? Where will 10 be inserted?
15.
Left of 13.
Sorry? Hello? Yeah, so what will you do for the insertion of 10? We first put it over here, right? We first put it over here and then we do a heapify operation, right?
Yes, ma'am.
Yes, ma'am.
Yeah, so how do you perform the heapify operation? Do we need to perform a heapify operation here now?
No, ma'am.
No, ma'am, it's not needed because 10 is less than 15, right? So
Okay.
it satisfies.
Then what do we do? Then what do we do?
Then insert 17 at the right of 15.
Okay, great. So we put 17 over here and then what?
Now we need to do.
Now
Now
we
we need to
We
do.
need to do the
heapify.
heapify operation. Okay.
So we need
how
to
do
bubble
we
up.
perform the heapify? Tell me the steps one by one, and we will do finish it off. Yes. So we have 20 over here. We have 18, 13, and 12. Okay, here is 13, then there is 12. And here we are having 15 and 17. This is getting a conflict. So what do we do?
Let's swap them 17 to 15 and 15
Sorry,
down to
sorry,
17.
sorry.
Swap with both the numbers. 17 goes up and 15 comes down.
15 comes down.
Yeah. So I get 10 over here and then 15 over here. Then what?
Ma'am, it ends, right?
It's done, right? So our list will become 20.
It's 20, 18, 17,
17.
13, 12, 10, 15. So that's option D.
Okay, that's option. That's which option? Option D. Okay.
Yeah, option D.
Okay, let's go to the next problem. Let's just quickly solve these problems. Okay. A 3-array maxheap is like a binary maxheap, but instead of 2 children, nodes have 3 children. A 3-array heap can be represented as a list as follows. The root is stored at location A0. Nodes in the next level from left to right are stored from A1 to A3.
Ma'am, this one was solved.
Solved?
Yeah,
Yes, ma'am.
it was not directly in the mock, but it was in the one of the questions which sir took as an example to explain this.
Okay, great.
3-array, right?
Okay, fine.
This one was not solved, so we can solve this one.
Okay, great. Consider that the following elements are inserted in the given order to create an ABL tree. 36. Oh, shit. Sorry. Okay. Consider that the following elements are inserted in the given order to create an ABL tree. Okay. 36, 40, 32. Okay, 36, 40, 32. Then there is 18, 72, 5, 35, and 34. Okay. Now the question is, which of the following is the leaf node? Okay. Which of the following is the leaf node? Which one will be the leaf node? Construct the ABL tree and we will be able to find the leaf node.
Ma'am, 534 or 72?
Sorry, 5?
34 or 72?
44. Any other answers? Okay, let's construct the ABL tree then, okay? We'll insert the nodes to the ABL tree one by one. First of all, we are putting 36. This will be fine. Then we will put in 40. Okay. Where will 40 be inserted?
Right of
Come on, let's finish it quickly. Yeah. 40, where will be inserted?
right side of the
Right child of 36. We go to 36. We see 40 is greater than 36. So we insert 40 as the right child of 36. Okay. Then we have 32. So we go to 36. We start from the root of the tree 36. 36 and we compare with 32. We see that 32 is smaller than 36. So we insert 32 to the left child of 32. Now this is balanced. 40 is balanced. 36 is also balanced. So we don't have to do any rotations here. Then we go to 18. 18 is, we have to insert 18. So we go to 36. We see that 18 is less than 36. We go to its left child. 32. 18 is less than 32. So we insert 18 over here. Okay. As the left child of 32. Now, are the nodes balanced? This is balanced. This is balanced. 1 and 0 balanced. So this is 2 and 1. So this is also balanced, and 40 is also balanced. Okay.
Yes.
Now we insert 72. 72 is greater than 36. So we go to the right child of 36.
Right of 40.
So we insert it as right of 40. 72. Okay.
Till here,
Now,
everything is fine.
yeah,
After
this
this,
is
the thing.
balanced. 40 is balanced. This is 1 and 0. So 40 is balanced. 36, 2 and 2. So 36 is balanced. 32 is balanced. 1 and 0. And 18 is balanced with 0 and 0. The left child and the right child. Height. Okay. Now we insert 5. So 5 will be inserted where? So we go to 36. 5 is less than 36. So we go to the left child of 36, which is 32. From 32, we compare with 5. 5 is less than 32. So we go to the left child of 32, which is 18.
Left
5
of
is
18.
less than 18. So we insert it as left child of 18. Okay. Now which node is unbalanced? There is a node which has been unbalanced. So which node is unbalanced?
32.
32 is unbalanced. Okay. So how do we apply the rotation?
LL. Left rotation.
Left rotation where?
Means like you can put in, move the 18 to the up, and 32 will be on the right side and 5 will
Yeah,
be.
here you are rotating like this, right?
Yes, obviously.
So we have 36 over here. We had 40. Then right child of 40 was 72. Left child of 36. We are rotating here now. This 18, 32 edge. So 18 will come up, 32 will come down. Okay. So goes up, 5 comes here, 32 comes over here. Anything else is unbalanced now? Or everything's balanced? 32 is balanced, 5
It's
is balanced,
balanced, man.
18 is balanced, 72 is balanced, 40 is balanced, and 36 is also balanced. Okay. So now let's go to the next element, which is, which one did we insert? 5 we inserted, then 35 we will insert. Where will 35 be inserted?
Right of 32.
We go to 36. 35 is less than 36. So we go to left child. 18 is less than 35. 35 is greater than 18. So we go to its right child. 32. 35 is greater than 32. So we insert it as the right child of 32. Okay. Now is anything unbalanced? Let's see. 72 is balanced. 40 is balanced. 1 and 0. So this is balanced. Now 35 is balanced, 0, 0. 32, 1 and 0. So this is also balanced. 5, 0, 0 balanced. 18, 2, and this is 1. So this is balanced. And 36, the height for this left child is 3. Height of the right child is 2. So 3 minus 2 is 1. So this is also balanced. Okay? Hello?
Yes, ma'am.
Hello? Okay. Hello?
Yes, ma'am.
Yes, ma'am.
Okay, just confirm sometimes that I'm connected, okay, when I feel like I wasn't connected at all. Okay, then we go to 34. Now for 34, we compare 36 and 34. 34 is less than 36, so we go to its left child. 34 and 18, we compare. 34 is greater than 18, so we go to its right child. 32 and 34, we see that 34 is greater than 32, so we go to its right child. 35 and 34, we see that 34 is less than 35, so we add 34 as the left child of 35. Okay, so now which of these nodes is unbalanced?
32.
32.
Sorry,
32.
32 is unbalanced, and
It's a left and right rotation. 18 also
Balance.
is unbalanced.
36 unbalanced.
36 also.
36 is also unbalanced. Okay, so now where will I perform the rotations? Where will be the first rotation?
32.
From the bottom. 32.
Yeah, this edge will rotate, right? Here we will perform the rotation will be like this, right? So we will have 36, then 40 and 72, and this side we will have 18 here. 5 comes here, and here we will rotate this. 35 goes up, 32 comes over here, and 34 comes over here. Okay, next what happens? Which one is unbalanced? 1, 2, 1. Shouldn't there be like 2 rotations? Oh, yeah.
Right left
Ma'am,
rotation.
you are
So
using
first swap
No,
wrong.
between
I
30.
was wrong here. This is the left child of 35.
Yes,
No?
so L
Yes, ma'am.
RL
Yeah.
rotations.
So where will I be performing the rotation first?
What's the left child, ma'am?
Left side.
Sorry?
Left one, ma'am. 35. At 35, we need to perform the rotation.
35 will be the performing the rotation here.
Yes,
Ma'am,
ma'am.
you just need
34
to
before.
swap.
34 will be the root. 32 will be the left
34
child.
becomes the root, and 32 and 35 will become the child.
32 is left child and 35 is right child.
Yes. Just swap the 34 to 32 first of all. That will become the root, and after that you can just move. 35 is already on the right side, then move 32 on
No. I am asking you the steps. What is the first step? You are skipping
The
a
first
step.
step is
And you
to
are
swap between 35 and 34. 34 goes up and 35 will be the right child of 34.
yeah, you are performing a rotation here, right? So here we have 18, that is 32. Then we will have 34 over here, and then we have 35 over here.
Yes,
Then
okay.
we
So
will
now this
perform.
is a right situation. Then
Right rotation.
Sorry.
Now we will perform right rotation. So that means 34 at 34 we will perform that.
Yeah, here we will
It will
perform a
move.
rotation, so we become 36. This is 18, 5. Here comes 34, 32, 35, 40, 72. Okay?
Yes, ma'am.
Hmm?
Yes.
yes, ma'am.
Okay, that's it. So what are the root nodes?
5, 32, 34, 72.
Sorry,
Not
the
34. 5, 72, 32, and 35.
5, 72, 32 and 35. Okay.
That 34 is not there. I'm seeing that. Yeah.
I think we did something we made a mistake or something. Sure, this is correct?
Yes, ma'am.
Yes, ma'am. When I solved, I got this. And I used this one only. Means just that is you said no. I skipped that step. I did it in one go. That's all.
Okay. Okay, yeah. Yes, this is correct. Okay. Okay, let's go to the next problem. So 5, let's see, check the answers. 5, 32, 35 and 72. These are the 4 leaves, okay? Okay, let's go to the next problem. 11th one solved. Hoffman code algorithm.
No, ma'am.
Sorry?
No, ma'am. It was not
No,
solved.
ma'am.
But I think it is one of the question which is in activity or maybe in graded assignment. I'm not sure. I have seen this question somewhere else also.
Okay, then tell the solution. You've seen the question. Great.
It will be 2 and 3. First one will be wrong because it just contradicts the entire Huffman theory. It
Which
says
one?
no x is depth, x is at depth is smaller than leaf labeled by y, then frequency of x is less than frequency of y. It should be frequency of x is greater than frequency of y, no? Because the lesser the means the more the depth, that means lesser the frequency. because
Okay.
for more frequency, we need lesser bits so that we can compress the entire data while
Okay.
performing the application.
Yeah, that's the actual explanation. So that is why we will be, this is false, because this is true.
Less frequencies now, na less frequencies close to leaf nodes.
No, 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 never. Just think about, like, if you say A has five times A has occurred and a B has occurred only one times. If you use the Huffman tree to build that, then in case of A, if you are saying that it has less frequency, right? It is closer it is it has what you said. You said that it is at depth, right?
Frequency less frequencies
Hmm.
at depth, na frequency less frequencies at depth, na.
Less frequency is at depth. Yes, that's right. That's right. But for more frequency, it will be smaller. Means it will be closer to root, so that the code, that Huffman code that is generated, prefix code, right? That will be smaller, so that we can condense the information. It's type of a condensing information. It is used in security practices and networking and all as well.
Sorry. Okay, what is the answer? Tell me the answer.
Ma'am, 2 and 3.
2 and 3 is the answer. Why is 1 is false?
I explained that, right?
Okay.
I think if x is at less depth, then x frequency should less, na.
No, no, no. X frequency should be X. You are saying X is at less depth, right?
Yeah.
If X is at less depth, that means frequency will be more.
Less frequencies at left down, ना. आई एम सेइंग जो कम फ्रीक्वेंसी के होते हैं वो सबसे नीचे होते हैं, वो मैं कह रहा हूँ इन हफमैन ट्री.
सही सही, अब सही बोला.
Then the depth will be greater, no? Okay, let me ask you.
x अगर y से नीचे है तो x की फ्रीक्वेंसी लेस ही होनी चाहिए ना.
हाँ, तो then the depth of x will be greater than the depth
Greater,
of y.
depth should be greater. No, it is saying smaller, right? It is saying smaller, right?
First is true, na.
No. Wait, you are getting a little bit confused. See, depth of x is smaller than depth of y. What it means? That means that x, the number of edges from root to x is less than the number of edges from root to y. That is what is the meaning of this particular statement. So it means that x is somewhere up and y is somewhere down in the tree.
Okay, ma'am, understood. So first is wrong.
Sorry? First one is wrong. Okay.
Yes, ma'am, first is wrong.
Yes.
Why?
Sorry?
I'm asking him why it is wrong.
Okay, so we have x is up and y is less, right? So what happens now when you are constructing the Huffman tree? I will give you two reasons. Okay, one reason he already gave. When you are constructing the Huffman tree, you are taking the edges with label which have lower frequency, and then you are merging them to create new nodes, right? So what happens is the values with the lower frequencies are towards the down of the tree, towards the towards the bottom of the tree at larger depths. Okay, so every node which have the lower frequencies, if you are taking two leaves and you are comparing, the leaf which has a smaller depth will have a higher frequency. Okay, because you are taking the lower frequencies first and then you are merging them to create this this kind of a structure, right? You are merging them to create this kind of a structure. Remember? So what you have merged initially, all of these were having smaller lesser frequency as compared to the nodes over here, right? Because this one is being merged with something with a larger frequency as compared to these values. So all of these nodes are towards the top of the tree will have larger frequencies as compared to the ones towards the bottom of the tree. Okay, that is the first argument. The second argument is why this is done is basically in Huffman tree. The idea is when we are assigning a coding, so a letter, let's say a letter, one particular letter is occurring multiple times. Let's say in state, STATE, consider the word state. Here T is occurring 2 times. So I don't want 5 different binary digits to represent T. So my value, so my length will become like 10. But if I use like 2 digits to represent T and 3 digits to represent all the remaining letters, then what will happen? I'll have 2 plus 2, 4 for T, and 3 plus 3 plus 3, which is 9, and it will be done with 13 letters. But if I am taking larger number of letters for the one with the larger frequency, then I will be, my length of the encoded string will just keep on increasing. So that is why what we want is the one letter which occurs very frequently, the most number of times, should have the smallest code. Okay, that is why, so that it will have a smallest code, we want the letters with the larger frequencies to be closer to the root as compared to the ones with the lesser frequencies. Got it? Any doubts? Okay, I can't hang on, let me just pull you in. I can't really see what there's a saying or something.
Ma'am, you are audible.
Okay. Okay, great. Let's go to the. So there are no doubts with the 11th question, right? Okay, 12th question. There is a machine. I'm assuming this has not been done,
It's
right?
not. It's not.
Okay. So there is a single machine, one by one you have to perform n jobs. Each job I has the time Ti required to complete, and deadline is Di. It takes time Ti and Di deadline. Some jobs may complete after the deadline, so the lateness of each job is defined as, if it is greater than, if the time of completion is greater than deadline, then time of completion minus deadline is your lateness, otherwise it is 0. Suppose ML is the maximum lateness of all the latenesses. You have to minimize the maximum lateness. Okay, these are the jobs. What will be the minimum possible value of maximum lateness? Go ahead. Yeah, what is going on in the chart?
Ma'am, it's easy. Here we need to just find the maximum lateness that can occur, right?
Sorry, minimum possible value of maximum lateness.
Maximum lateness, yeah. So it's like what maximum late it can be, right? So we will just add the completion time. I mean, subtract from the completion time. Can you move a little bit up? I actually didn't remember the
So
term. Just
what
add and
exactly you are doing? Explain the algorithm.
okay, so algorithm is simple. First of all, we will start with 0, right? And then we will keep on adding the time. If our time is less than the deadline, then lateness is 0. Else, we will subtract the completion time, deadline minus the completion time, and the mod value of it. So that will give us. And next, we will keep on adding the time in the required time for the completion sake for the next ID. So first of all, we need to sort the deadline itself.
You have to sort according to what? Based
Deadline.
on what?
Deadline. Based on deadline. That is completion. This deadline, right? Deadline 6,
Yes.
7, 8, 9,
Yeah.
12.
Okay.
And in ascending order. I generally do it in ascending order.
Okay. So in ascending order, which one should come first? So let's sort the job IDs.
16.
Okay, yeah, job IDs. So first of all, we will have 6, then we have 1. Job number 6, then job number 1, then
2.
Job number 2, job
3.
number 3, job number 4, job number 5. Okay. So now let's do this. We'll start at time point 0. Okay, we start at time point 0 and job number 6 takes how much time? 2 units. Okay.
Hmm.
So J6 ends at 2. Okay. Then what happens? So the deadline for J6, sorry, the lateness for J6 will be equal to
0, because it is completing before the deadline, right?
yeah. So the lateness for job 6 will be 0. Then we have which one? Job number 1, and it takes 4 units of time. So it will be over at 2 plus 4 is 6. Okay.
6 units. Hmm.
Yeah, this is where J1 ends. Okay. So the lateness for this will be
0.
Again 0.
0. Okay. Then what job is that? J2. J2 takes 2 units of time. So it ends at 8. So the lateness for J2 is
1.
1.
Or
Okay.
-1, whatever you say.
No, it will be 1.
Mod
Because
we take, na?
no, according to the formula given here, you are not supposed to take any more.
Okay, so time of completion minus deadline, right? So
Minus deadline. Okay. So this is 1. Okay. Then which job did we complete here? Job 2. Then we have job number 3. So job number 3 starts at time point 8 and ends at time point 9. Okay.
9, 9, 9.
1 hour is required, so it ends at time point 9. So the lateness will be
1.
1. Then we have job number 4, which starts at time point 9 and takes 4 hours, so it ends at time point. When will it end?
13.
13?
13. It will end at 13. But the deadline was 12, so it
12.
is late by 1
1.
hour. Okay.
Hmm.
Then we have job number 5. It starts at 13 and it takes 3 hours. So
16
it
total.
ends at 16, right?
So here it will be 2.
It will be 2. So the maximum lateness value is
2. Same. I also got.
okay. Any doubts?
No, ma'am.
Hello, any doubts?
No, ma'am.
Okay, great. Let's go to the next question then. It's related to this question only.
Ma'am, in case of tie, right? In case of tie, then how it should proceed?
What
Means,
time? What time?
means like time required and deadline, right? For 2 jobs, time required and deadline are almost same. It's like they are same. Let's say 4/6 and 4/6.
4/6 and 4/6. The deadline is same. Yeah, then it doesn't matter, right? Whether you have job 1 or job 3. Why does it matter? Job 1 and job 3 are basically the same kind of a job running 2 times. So whether you
Okay.
perform job 1 or first or job 3 first, it depends upon whether you like 1 better or 3 better.
Okay.
Okay. Okay. Next. Give me 1 moment. I will just put my laptop on charge. Okay, I'll be back.
Ma'am, after solving all this mock question, will you solve a PYQ paper?
If we have time.
Means what is your deadline for time? 10:30, 10?
You tell me.
No, I can't tell you because you are the instructor. You are the superior person.
I'm not the superior person. I am the. Okay, I should not be saying anything today. I am extremely sleep deprived. Okay. Okay, so let's go to the next question.
Ma'am, I have a doubt.
Yeah,
Ma'am, what if we don't arrange it in ascending order and just start to solve it?
sorry, your doubt was not audible clearly.
Ma'am,
What
what
was your
if
doubt?
we don't what if we don't arrange the deadline in ascending order?
And then you just start solving it randomly, whichever comes first.
Yes, ma'am. In that
Sorry.
way, yes, ma'am. If we do that in that way without arranging in ascending order,
Okay.
so will
Then you
there
will
be
be
any problem?
having random lateness for everything. See, that's what happens if you don't do this ordering thing. No, then what will happen? You are just using everything is having the same amount of priority. So you don't care. See, like for example, what happens? Suppose the deadline for 6 will be 1. For the deadline for 6 was supposed 2. Okay, you are not doing this any random ordering on this. Okay, you are just doing this sequentially. We will do job number 1 first, then job number 2 first, then job number 3 first, and so on. So by the time you reach 6, you will be having what? This will be 4 plus 2 6 plus 1 7 plus 4 7 plus 7 is 14. So you will only point when you will be able to start 6 will be at 14, at 14th hour. Okay, so you're starting at time point 14 and you are going for 2 hours more, which will be taking your 16. So your job number 6, which has the highest deadline, is getting over at the 16th hour. So basically, if these jobs are some kind of a patients in an OT, your sixth patient is dead now.
Yes, ma'am. Got it.
Got the solution. Why you have to use this ordering?
Yes, ma'am.
Okay, so that is why you always in every problem, no, in every scheduling problem, which one you need to do first, which one you need to do second. That's why these are called scheduling problems. You have a bunch of things to do, so you need to decide which you have to do first, which you have to do late. You have to decide an order on this. That is why the term scheduling is coming up. Okay, so this order is the main thing in these problems. The remaining portion, these are all just mathematical calculations. Anybody can do it. But what everybody cannot do and computer scientists can do is finding this particular scheduling. Which scheduling will be the best to fit for a particular problem that is given to you. Okay, that is why these problems are called the scheduling problems. Okay, that is something that computer scientists can do, others cannot do. Okay, so this is the main portion of the thing. If we, the portion of the problem is finding this schedule, which one you have to do. You have a bunch of tasks to do, you need to decide which one you have to do first and which one you have to do last. Okay, so that is the point here. Okay, let's go to the next problem. Any other doubts or any other questions?
No, ma'am.
Okay, great. Okay, which of the following greedy strategy would always work correctly for the given problem scenario? Okay, this is basically the thing that we already discussed. This
First
is
step.
basically the scheduling. With what scheduling order that we should be following, which is basically the second one, right?
Yes, ma'am. I have one question here.
Deadline is the earliest.
The
Yes.
question is, means on in which scenario we should pick first one and the third one.
There are several interval scheduling problems. You just search for, sorry, not interval scheduling problems, just job scheduling problems. You try to search job scheduling problems online, no? You will
Mhm.
get a bunch of problems. Some of them will require the first one, some of them will require the third one, some of them will require the second one. Okay, there are problems where you will be requiring this.
Job scheduling, you said, no?
Yeah, job scheduling problems. Search online for job scheduling problems.
Okay.
The question that you asked is basically it is covered in the advanced algorithms course. It used to be,
Okay.
I don't know, I think the syllabus has changed for that. But if you look into the algorithms, the different problems on this, then you will able to find there are multiple job scheduling problems. Some of them require this first option, some of them requires third option. But to make your problems easy for you, we are concerning on this second option, because this thing, deciding this thing is like the hardest. Which one you should take, which one should choose to schedule, what order you should use to schedule, that choice is the hardest in scheduling problems. Okay.
No,
Okay,
I am
let's go back.
asking in
Sorry.
case of categorization, like we have no divide, conquer, grading algorithm. So these come under greedy algorithm. So all will come under greedy algorithm only, right?
Actually there are some that comes under this DP algorithm also.
Okay.
Divide and conquer, it will not, you will not find scheduling problems. Because for scheduling problems you cannot divide and divide a set of problems into two parts and then you schedule each of that will not work half of the times. Okay. DP problems, there are some DP algorithms and some greedy algorithms that can that type solutions. Okay. Okay. Question number 14. Inversion pair. This is a very important question. I have seen this question in bunch of PYQs. Okay.
Ma'am, 190 is the answer.
Sorry?
Ma'am, 190 is the answer.
190 is the answer. Why? You said 190 is the answer. Now tell why. How will
Formula n into n minus 1 by 2.
And the formula is n into n minus 1 by 2.
How did you get this formula n into n minus 1 by 2?
Ma'am, sir told us this. And ma'am, if the array is sorted in descending order, then this will be the answer.
But why?
Okay, go ahead. But why? See, I asked to explain the concepts behind each of them. If you know the concept, then go ahead, tell it. Why?
Like if we take example like 5, 4, 3, 2, 1.
Okay.
Yes, ma'am. So the inversion for 5 is 4, for 4 is 3, for 3 is 2, and for 2 is 1. So if
basically
we
number
count
of elements.
yeah, the number of elements. If we count them, then it will come to 4, 10, ma'am. So it is 5 into no. Yes, ma'am. It is 5 into 4 by 2. So that's why I found the formula n into n minus 1 by 2.
Yes, you're right. Okay.
Right.
That is actually the solution. So the maximum number of inversion pairs occurs when your array is in the descending order. So when your array is in the descending order, you will have the maximum number of inversion pairs, and the total number of inversion pairs in such kind of an array will be equal to the number of elements to the right at every index. So for every index, whatever number of elements are on its right, that will be the number of inversion pairs for that particular number. Okay, for that particular index. So if you keep on totaling it, you will have n plus n plus 1, n plus n minus 1 plus n minus 2 plus n minus 3 and so on up to 0. Okay, so if you keep on adding this, and that's why this is basically a sum of n integers, the first n integers, that's how you get n into n minus 1 by 2. Okay, that is exactly the solution. I don't know your name, so whatever you, whoever said the answer, it was correct. Okay.
My name is Shivam.
Okay, great. Actually, I can't see who's
That question.
Sorry?
But in this question number 14, there is no mention of that. The size of array is 20, but the array is sorted in a descending order. It is not mentioned.
Maximum number of inversion is given.
Okay.
It is saying that you have the maximum number of inversion pairs in this array is A of size 20. The only scenario when you have maximum number of inversion pairs is in this, let's say this is an array, okay? in the first element. This is not your error. This is
Yes,
your
ma'am.
error.
Got it, ma'am. Got it.
Okay. So the maximum inversion pairs will occur for the first one, maximum inversion pairs for the second one maximum inversion pairs for the third one, and so on. This will occur when your array is in the descending order.
Ma'am, if it's in ascending, then it will be minimum, right?
Yes. If it is in ascending, then it will be 0.
Hmm.
0, ma'am.
That is the minimum value. Okay.
Mhm.
Okay. Question number 15. Median of medians with block of 7 elements. What median value will be returned by the given MOM function for the following list?
Ma'am, in this question, the first comment should not be given. That solves the question itself.
That's fine. We are making it easy for you. So you solve it.
Okay.
Hmm.
We can split all the arrays means into 7 elements and then sort it, and then we will get 20. If
Actually, it contains 27 elements instead of 28. That's why the last array will contain 6 elements only.
Yes.
And 20 will be your answer after sorting and everything you've done.
Yes.
Sorry?
No problem with that. If the last array will have 6 elements, then no problem.
No problem.
We will choose the second index element.
Okay, can somebody tell what's going on? Explain me what is going on.
Nothing, ma'am. We are saying something about
She is asking for what this code is doing, I think, right? Ma'am?
Oh,
Yeah.
the
I'm
code is
saying, tell me the solution. I'm just asking, tell me the solution because I have to tell the solution. Tell me the solution.
First in the if condition, the code is checking that if the length of the list is less than equal to 7, what we can observe that it is not. So we will check for the for loop here. Then this inside this for loop, in each and every iteration, it is dividing the list into 7 equal halves.
Okay.
So then you can take each and every array and which will contain 7 elements.
Okay.
After doing that, first 3 array will contain 7 elements and 6 will be remaining. So the last array will contain 6 elements. Then you have to sort each and every array in the ascending order, and then you have to find out the min using the function, which is
Okay. So what is the answer then?
20.
Answer is
20.
20.
Hmm.
I'm getting it. Okay, wait.
20.
Okay. Yeah, I put it wrongly. No, that's why I was getting it.
Yes.
So this is 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay. So then we sort each of these, right?
Yes, ma'am.
Yeah, each of these we sort, then we get 3, 4, 5. 3, 4, 5, then 7, 9, 10.
7, 9, 10.
7, 9, 10. This part will give 1, 2, 6, 8. 1, 2, 6, 8.
12, 15, 19.
12, 15, 19. Okay, the third will be 14, 2,
14, 18, 18. 23, 24, 25.
21 is there. 21,
21, 23.
24 and 25. Okay, then finally this one also we have to sort. So we will have 11, 2 17s, 20, 27
26 and 27. 26 and 27.
Okay, then what do we do?
Take the mid.
Take the
Mid.
mid of each. What is the mid of this?
N by 2 means like total number of length divided by integer division 2. So that
Okay,
will be
into
7 divided by
division
2. So that will be third element. So 7.
7. Okay, so 7. See, when you're asked to find the median of a list of elements, no, you just find the middle values. There are 3 elements to this, 3 elements to the right of this, so this is the
Okay,
median.
okay.
That is how we
Then it.
compute median. That's the formula to compute median. Okay.
Mm-hmm.
If it is even, then you take the 2 middle values and find this average of that.
Okay.
Okay. So for this one, the median
8.
is 8. For this row, the median is 21.
25, 21, 21, yeah. And
Yeah.
then
In
20.
this row, this is 20. Then what do we do?
Again sort.
Sort. So we get what? 7, 8, 20,
20,
and
21.
21. Okay. Then what?
Take the median now, as you said, right?
Yeah, here the median is length of L divided by 2. So we are having 4. 4 by
4
2
divided by 2. So that
gives 2. So 0, 1, 2 is 20. Okay.
right.
So mathematically it was supposed to be 8 plus 20 by 2.
Mm-hmm.
But here we are defining the median as length of L by 2. So you
That's why I was taking earlier also and divide 2.
yeah, length of, see, from where we are getting this plus this by 2, you know, this is length of L by 2. This is length of L divided by 2 plus 1. Okay, that is where you will be getting
Mm-hmm.
this. Sorry, not this is length. This is actually from 0 to L minus 1. No? So that's why it's creating confusion.
Mm-hmm.
It will be something along those lines. Okay.
Okay.
Anyways, let it be there. Okay, so this is where was I? Yeah, so this is
the
the
median.
median. This will be the median value 20 that will be returned by this algorithm. Okay, any doubts in this? Okay, then next question. 16th. Consider the following recurrences and choose the correct option. Okay, go ahead. I'm not solving this. I had solved this during the quiz 1 solution. We had discussed this kind of a
Option
solution.
B, ma'am.
Option?
B.
B. But for the second case, I mean, it's like for the second one, we will get 1, right? So we will use the third case of that master theorem, right?
Mm-hmm.
So
Master
Log
term, the master term has been covered?
yeah, master theorem has been covered. It was covered by TA and as well as sir also.
It's there in the.
Yeah, it's in syllabus of the recursion tree.
Okay.
Not discussed by professors, but it will help us.
TA by TA has done right.
Okay, great. So go ahead. Let's discuss this recursion tree first, and then we will discuss the master theorem. So discuss the recursion. Solve it using the recursion tree first. Let's solve one of them using the recursion tree. Okay. So which one do you want to solve using recursion tree? Whichever, choose one and give me the solution. I am not doing this. I had to discuss.
First one.
Okay, tell the solution then. Divya, right? Who
Yes,
told me
ma'am.
the first one? Yeah. Go ahead, tell me the solution. You chose the first one. Tell me the solution now.
Ma'am, recursion tree solution is not that much handy with me because I
Sorry?
used to do it. I'm not that much handy with the recursive tree solution because I used to do it using master theorem.
Okay. Recursion
Ma'am,
tree
I
is
can try.
handy a lot. If you're not that handy, then learn the recursion tree algorithm more than the master's theorem because there are problems that cannot be solved with the master's theorem. Recursion tree will help you there. Okay, especially problems where you have n minus 1 thing in the recursion. Okay, so anyways, let's go to the recursion tree. So we have n in the first set of integers. Sorry, in the first list we have n integers. So we will be having the node with length n in the first part. Then we are dividing this into
9 parts. 9 parts of
each
n
of
by
n
3.
by 3. Okay, so there are 9 here. Okay, each of them is taking order n. So what happens? What is the time taken at this point? For this particular division to be done, this has been taking order of n. right? So now here what will be the time that will be required for each of
O
these?
of n by 3
O of
into
n by 3 into 9.
Hmm.
Okay, so we will be having 9 times O of n by 3. Right?
Okay.
Now for each of these we are going into 9 times again.
Yes.
And now what will be the size? N by 3 divided by 3.
Yes. So n
Right?
by 9,
So this
right?
will be n by 3 square. Use the square power terms, okay? N by 3
Okay.
square. Okay? Now we are having 9 terms over here. Same thing for the second n by 3, right? We will be having
Yes.
9 terms over here. Right? And each of them will be having n by 3 square. Similarly, here also we are having 9 terms over here. Each of them of size n by 3 square. Right? So the total number, how many of these n by 3 square lists will we be getting?
9. No, not 9.
9 times 9.
9
Each
times
of
9
9
into.
is getting divided into 9. Right? So we have 9 times 9, which is 9 square, order of n by 3 square.
3 square. Okay. If we
Got it?
further break
If
it,
we
right?
further go like k times, so k square of
9 to the power k at the kth level. If we are going this to the
kth
kth
level.
level,
Kth
we
level.
will have 9 to the power k times. We are performing this k times. So the height will be what? This is a height of 1. Okay? At the height, sorry, this is a height of 0. This is the height of 0. This is the height of k. Okay? At the kth height, this will be, the time will become what? 9 to the power k times order of n by
n by
3.
3 to the power k.
Okay? So now, what will be the maximum possible value of k until you get 1? What is the maximum possible of k until you get 1? See, this is what at the level k, let's say at level k, you are getting the size of the array is 1. Okay, so what happens at the level k? How many? What should be the size of the array? N by 3 to the power k. That is where you are getting this n by 3 to the power k, right? This n by 3 to the power k is coming from the size of the array. Your size of the array is getting divided by 3 at every level. So at the kth height, your height, the size of the array will be n by 3 to the power k. Right? So now I am claiming that at the kth height or at the height level h, at the height number h, what happens? The size of the array is equal to 1. So n by 3 to the power h will be equal to 1. Do you agree to that? Got how I got this? Is this clear? From where it came?
I'm not getting actually.
Okay. So what happened is at the level k, what happened? You got this time, right? How you got this time now?
That's okay. That's clear.
How we got this time? Because our array is getting this n by 3 squared. When I go to the third level, will become n by 3 cube. The length of the array is 3
3
cube, right? So at the level k, my array will have a height length of n by 3 to the power k.
Okay. Okay. Yes.
Right? So at the level h, I am telling you this information that at the level h, my array has a length of 1. Every array has a length of 1. Okay? I am asking you what is the value for h. So how do you compute that? I know the formula is n by 3 to the power k, right? At the height h, array length will be equal to
1.
n by 3 to the power h. I am telling you that at this particular height, the array length is equal to 1. So that is where we are getting n by 3 to the power h equals to 1.
Okay.
Got it? Then you just equate it. N is equal to 3 to the power h. So your h will be equal to log of n to the base 3. Got this?
Okay. So
Clear?
means basically you are transferring 3 to that side. So to get the h, right, we need to add log to that. Okay, understood.
Yeah. Okay. So
Okay.
now what now we will compute the total time required for the problem. Like for this algorithm. Okay, what is the total time required?
Okay.
At level 1 it takes order of n. So order of n plus 9 times order of n over 3 plus 9 squared times order of n over 3 squared and so on. Until what?
Why?
9 to the power h times order of 1.
Hmm.
Right?
Hmm.
9 to the power h times order of 1. You agree to that?
We just computed that, right? This particular thing.
Yeah, h we computed. We computed the value of h. I'm just saying this is the general
Yes.
formula.
Yes. Okay. Okay. Okay.
Okay, so instead of taking these order notations, I'm just going to remove the order notation and I'll write something like this. Order of n
You will get
plus
a GP.
9 times n by 3 plus 9 squared times n by 3 squared plus 9 to the power plus dot 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 up to 9 to the power h times n by 3 to the power h, which is basically equal to 1. I know that. This is basically 9 to the power 0 by 3 to the power 0. Okay?
Mm-hmm.
This is your GP. Okay? Tell me the solution to this GP. So what is happening here is, this is basically, I'm rewriting it as, I'm cancelling this 3 with this. There are two threes. This is 3 into 3 and this is 9 into 9. I'm cancelling this 3 with 3, this 3 and this 3. Okay, so I'm getting something along the lines of 3 to the power 0 times n plus 3 to the power 1 times n plus 3 to the power 2 times n and so on up to 3 to the power h times n. Do you agree to
Okay.
that?
Yes.
Yeah.
Okay. Makes sense.
So this is equal to order of n times 3 to the power 0 plus 3 to the power 1 up to 3 to the power h. Got it?
Yes.
Yeah. Now tell the solution.
You
I
took
don't.
n common, right? You took
Yeah, I
all
took
the
n
n's
common.
common.
Ma'am, now you have to do like 1 minus a power GP
Why
solution.
1 minus a power?
I actually forgot the formula.
Yeah, the formula was something along the lines of a into r to the power
Hmm.
number of elements minus 1 divided by
minus
r
1
minus 1.
divided by r.
Actually, I
Okay?
have studied in class 12th a lots of time.
Yeah, me too.
That's why I forget.
Yeah, everybody forgets. That's okay. You don't have to feel bad about it. So this is a is equal to 1 here because our 3 to the power 0 is our a. So a is 1. So 1 into r to the power r is 3 here. Okay. And then is basically we are having h elements. This will be n
Ma'am,
minus.
R is common ratio, na?
Yeah, the common ratio is 3.
R is common ratio.
Okay. So
Hmm.
this will be divided by 3 minus 1, which is equal to 2. Okay. And here we will be having something along the lines of 3 to the power h plus 1 or h minus 1 or h something minus 1. 3 to the power something order of h. Okay. So now we know h is equal to log n to the base 3. Right. So you use this formula over here. And when we do this 3 to the power log n base 3, we will, using the logarithmic rules and everything, this is actually equal to n. You can swap this n with 3 here. Okay, you will get n to the power log 3 base 3. This will become n to the power 1, which is equal to n. Okay, so this is just a mathematical rule for logarithm. So you will get this is order of n times n minus 1 by 2. This is equal to order of n square. That is your answer, right? Did I make any mistake or this correct?
Yes, so that's O of n square.
Yeah. That was the answer, right? Second one was the answer, right?
Yes.
Yeah, so O of n squared is correct, right?
For T1 it's correct, right?
Yeah, I was solving T1 only.
Mm-hmm.
I am not solving T2. You can solve T2. Okay. Any questions?
I have the question for T2 only, but I mean, since you are not using master theorem, I can't ask.
Okay, let's tell me the what is the question with Master's theorem?
Basically, means this T of n square, right? We are solving it for the third case of the master theorem, that is n of r is equal to that 1, right? In case of 1.
Wait. Where did you get the third case of Master's theorem?
So basically, I use this 8t of n by b, that O of n square. So work done is O of n square, right? Okay, I got it, I think. The work is directly O of n square given. So why am I actually calculating? I can solve.
जो larger है वो होगा time
Yes,
complexity.
yes. Because this will translate to log 4 base 4. So that will be 1. So
X to the
If
power
there
what?
was On in T2, then it will be n log n.
if what you said?
If in T2 there was On, then it will be n log n.
Okay.
Because then both will be equal.
Yes.
Okay.
I
What
didn't
about-
solve that.
Yeah, I will not do Master's theorem for T1 and I will not do recursion tree for T2. That you can do that. Okay. What else you want to discuss? Hello.
Man, PYQ is actually. So I was
Do you
thinking.
have any questions from PYQ or you want every problem from PYQ to be solved?
Purnandu,
Yes.
you have solved a good PYQ question paper. What you have discussed with us? Can you mention the PYQ number?
Actually, I had quite a few of questions. Some of them were solved, but somewhere I had to. Means I had kept it for asking. Means they are not very good, but mostly the Jan term paper, right? This Jan term paper was really good. Means it has some really good questions.
Ma'am, I have a doubt. Like when to apply Dijkstra's algorithm? So,
Which algorithm?
in Dijkstra's algorithm, like it's doubt in a
Okay.
conflict. So, it is not guaranteed for negative edge weights, but in some of the questions they apply to it, and then they are getting right answers, right? For negative edge weight graph also.
See, if they can apply Dijkstra's algorithm to a negative in a graph with negative edges and they are getting the correct answer, that means that is an exceptional cases. You will find
Yeah.
multiple exceptional cases. Okay, such exceptional cases might exist. So, if you
Is there
have
any
any,
rule to identify that?
sorry.
Is there any rule to identify? Because in some of the questions they are giving like Dijkstra's algorithm is applicable to this, and then the graph has that. When I actually apply the algorithm, yeah, the answer turns out to be right. But how can I generalize this thing?
There is no generalization. There is no generalization. When you are given that apply Dijkstra's algorithm to this and find the answer, it means that we have applied the Dijkstra's algorithm to that and we saw the it is working and that's why you are given that particular graph. Okay. So there is no generalization on that. Yes, Punnendu.
Ma'am, actually, means like not generalization, but in yesterday session, actually, right? This same question was raised, and sir told that register algorithm can't detect the negative edge weights. Means like edge cycles. That's why if a particular graph doesn't have a negative edge cycle, then Dijkstra can be applied on it.
Negative as cycle.
Yeah, means like total sum will not be negative, right? In that case, uh, we can apply Dijkstra. I don't know, means like sir said that, so we just follow that.
Cycle, but it is okay. If there is no negative cycle, but there is a positive cycle, then what will happen?
Then we can directly apply Dijkstra, no problem with that. But again, cycle, I don't think it should be there
I
because.
don't know. I'm not able to get the actual proof right away,
Mm-hmm,
whether it will work or not.
mm-hmm.
But uh, the proof I'm not getting it right away, but it may be possible. What happens with a positive cycle? What happens with a negative cycle? I'll have to see.
Okay.
Look online. Your exam's Sunday, right?
Yes, ma'am.
Okay. What else you want to discuss?
Ma'am, there's few questions I dropped them in, means like the question paper itself I dropped in the comments. Ignore the first one, which was just few questions from March and Jan term. This paper is from 2024 December, so I was trying to solve them. Few questions were good, so we can discuss them maybe if time permits. It's no issue.
Okay, which question you want to discuss here?
Uh,
Match the following algorithms.
no, not this one. Question number 10. Question number 10.
Question number 10.
Question number 5. Fifth one. Yes, we
Wait,
can
wait,
have.
wait. Let's just scroll one by one. One is not. Oh, this is 2 is not.
Second
मैम
one.
एक बार मैम इस डिजेक्स्ट्रा को एक बार सॉल्व कीजिए ना, क्योंकि डिजेक्स्ट्रा में मुझे बहुत डाउट आ रहा था.
Dijkstra here.
This one.
Okay.
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 कैसे अनरिलैक्स करना है वर्टेक्स को विजिट करके, थोड़ा सा उसमें बहुत बार गलती हो रहा है मुझे बहुत.
क्या क्या गलती हो रहा है, फिर से बोलना.
मतलब विजिटेड मार्क करने के समय गलती हो रहा है सीक्वेंसिंग में. अब थोड़ा सा एक बार मैनुअली कर दीजिए.
क्यों गलती हो रहा है? They start from B, right? B is the source vertex. Start from B. So B is having 2 edges. So for F, the current distance is now 5 instead of infinity, and to 3 to E it is 3. Okay, and then I mark B with tick. Okay, done. Then from F and E I have to choose. Okay, so which will I choose? Obviously E, because
Smaller one.
So I am going to E. Okay, so I go to E. Now what will I do from E? This is one edge going out of E. So this will be 3 plus 1, 4 less than 5. So I will change it to 4. Then I have 5 over here. 3 plus 5 will become 8. So I will put 8 here. And what are the edges going out of E? There are no other edges going out of E. Okay. So now E is done. So like put a big tick mark over. Done. Then what you have, see, if you are doing like a computer, no, if you start thinking like a computer, then you will make mistakes, because computer is trained to do, it is a machine. We are not machines. Okay, you use the way which will make you feel better. If you use variables here, then you will start making mistakes. You will make this visited equals to 3, visited equals to infinity, and then you are changing it to 3. Then that will make you mistake. But you put the number here, visited equals to 3, done, right? And then this has been visited. So instead of like making a true, instead of changing the visited variable to true instead of false, you put a tick mark over here, or you cut this value. Then you will know this is no longer in play. You will, if you put a tick mark over here, then we will know this is no longer in play. Okay.
Ma'am, I have one question here.
Yeah.
After F, we are moving to C, right?
Yeah, wait, let's go to F first. So this is done, then we are going to F, because this is 4 and this is 8, so minimum is F, so I am going to F. Okay. So in then, F, what we are having, one edge is going out of F, so I will go via this edge.
Only A is possible.
A is possible, so 4 plus 5 will give me 9 over here. Nothing else is there from F, so I put a tick mark over F. Okay.
So I did the right thing only. It's okay.
Sorry? Yeah. So where we are going next? We are going to C. 9 and 8. So we will go to C. So from C, what we have 8. 8 is the distance till C. So there are two edges going out of C. One is this 2 and one is this 4.
Ma'am, from
So
A, you are visiting C. You're saying.
no, I am saying from C, I am saying what are the out edges from C.
Okay, C is before A, so yes, okay, makes sense.
Okay. So from C, the out edges are 2 and this. Okay. I go for this first one. This is
G.
2. So 8 plus 2 is giving me 10. And 8
10.
plus 4 is giving me
12.
what? 12.
12.
Okay. So now I can just put a tick mark over here. Okay. Then 9, 10 and 12. So I go to A. Okay. So from A, what are the out edges from A? This one and this one. So I'll go via this first. 9 plus 2, 11, but do a visited node, not required, not necessary. This one, 9 plus 3 is 12, do a visited node, not required, not necessary. So done, tata. And put a tick mark over A. Okay.
So the whole game is for visited, right? It is not like if we have some less weight, then we will assign it to other algorithms we have.
Yeah, exactly. If you are having less weight, then you will be assigning. But if the neighbor is already visited, then you will definitely not get a less weight.
मैम मतलब कि जब आप एक बार नंबरिंग करते रहे, मतलब इफ का ऑलरेडी 4 शॉर्टेस्ट डिस्टेंस हो गया, तो उसको ही हम जब एफ से किसी वर्टेक्स में विजिट करेंगे तो 4 + 5 और 4 + 1 समथिंग करके करेंगे ना? हाँ, अच्छा, ये यहाँ पे मुझे कंफ्यूजन हो रहा था।
4 + 5 लेके करना है। 4 इज द टोटल डिस्टेंस। अब घर से स्कूल 4 किलोमीटर है, स्कूल से रेलवे स्टेशन 5 किलोमीटर है, तो घर से रेलवे स्टेशन तो 5 किलोमीटर नहीं हुआ ना। घर से रेलवे स्टेशन 4 + 5 हुआ। ठीक है। So that's the concept. Till now 4 up to F the minimum distance is 4. From F to A the minimum distance is 5. So from B to A the minimum distance will be 4 + 5. Got it?
Yes ma'am.
Okay, so then we go to G. 10. 10 + 1 is 11. So we make this 11. G is done. No other out edges from G. From D there are no out edges, so D is done. Okay. I hope this is okay. What else you want to discuss?
Question number 10.
Consider the following binary search. Question number 10.
It's a minimum spanning tree weight. That one.
Yeah, find the minimum spanning tree. No?
ये आज ही सॉल्व किया मैंने।
So it's like how you solved it.
You have to use the Kruskal. At first you can, मतलब आप सारे वर्टेक्स लिख लीजिए एक बार, लिखिए, उसके बाद पहले आप स्मॉल वर्टेक्स को काउंट कीजिए, मतलब पहले A to D कनेक्ट कीजिए, B to E कीजिए।
Okay, great. A to D connected, B to E connected. फिर क्या कनेक्ट करना है?
उसके बाद F to E करिए।
F to E करूँगी. Okay.
और उसके बाद A to C.
Okay.
And C to S.
Okay, 1 minute रुको. Now explain me why E to F first came, why A to C came next, why S to C came after that.
नहीं ये तो ये तो आप क्रुस्कल से कर रहे हैं ना?
Yes.
तो क्रुस्कल से आप क्या करते हैं? सिर्फ आप एजेस को लिख लेते हैं, उसके बाद आप शॉर्टेस्ट डिस्टेंस पिक करते हैं और उसको जोड़ देते हैं। तो वैसे ही है, ये रैंडम पिक है ना क्रुस्कल का।
Yes, exactly. That's what I wanted to point out. So these numbers that he is talking about, ये जो पहले ये आया, पहले ये आया या पहले ये आया, that's completely random. You can choose any one of them.
लेकिन आप दोनों 3 जो है ना, उसके बाद 2 के बाद नेक्स्ट लार्जेस्ट कौन है? 3। लेकिन आप दोनों 3 में से एक भी को कनेक्ट नहीं कर सकते, क्योंकि वो एक साइकिल फॉर्म कर देगा वहाँ पे।
Exactly. So ये 3 and this 3 will be ignored. Okay, next
लार्जेस्ट 4 है और 4 के ऊपर 6 है, लेकिन हम 6 को क्यों चूज करें? यहाँ पे आप 4 है, 4 को कनेक्ट कीजिए, आपका स्पैनिंग ट्री खत्म। अब अगर आप उसके बाद टोटल कॉस्ट काउंट करेंगे तो आपका शायद कितना आएगा?
5 plus 2,
12
7, 8,
12 आएगा।
12. Okay. So the answer is 12. Punen, your doubt is clear or anything else?
Yes, yes. Okay. Any more questions? I don't think I've got it.
What
This one.
is
Question number 16. I think it has this component thing and everything. So can you just explain me, it's like the set union and all those? Like
और
what
ये
we
तो
are doing actually.
बिल्कुल कोड से कर दो, आसान है।
suppose
So
of
फाइंड 7 करने पे आपको 5 आएगा। उसके बाद क्या फाइंड करना है? 5 फाइंड करना है तो 4 आएगा। 4 से 3, 3 से 1 और 1 से 1, बस आंसर 1।
but why? Means क्यों करना?
आप कोड ही देखो ना, कोड को देखो, अच्छे से देखो तो आपको पता चल जाएगा।
run this code, that's what he's trying to say. Run this code on this input.
Find
Yeah,
set
for
u and find set v, right? X is
you are
equal to
given
find set
an
u.
array component representing the component array. Okay, this is the component array. Suppose after performing a series of union set operations using the provided pseudocode, the component array becomes this. This is your final component array. Okay, so this is not the input to the union set. This is the output from the series of union sets. Okay,
Okay.
now the question is on this particular thing we are applying find set of 7. So apply find set of 7 here.
That will be 5.
Find set of 7 is 5, then we apply find set on 5.
Okay, recursion. We are doing recursion again, right?
Yeah, you have to apply recursion. So find set of 5 is 4.
I
So
was
find
thinking
set
there
of
is input.
4 is 3. Okay, so find set of 4 is 3. So find set of 3 is 1. So find set of 1 is 1
And
because
that
this
will
one
match
is
this
1, that's
component
why
of
you have
u.
to end there and return
Okay.
1.
Okay. Okay.
Got it?
Ma'am, last question. I'm getting answer 18. I don't think that's right. Like, it is
This
not the
one,
right answer. This one. I'm getting answer as 18.
total number of bits needed to represent the message A, B, C, D, E, F. Okay, draw the Huffman tree first.
I will first. We have to sort it based on the.
Okay, sort it.
Then 2 and 5 we will take and combine
Yeah,
it.
see here, no, why do you need to sort?
अरे 18 बिट्स आ जाएगा, आप ड्रॉ कीजिए हाफमैन ट्री, आराम से होगा।
2 and 5. So you merge B and D. You get B, D. Okay, so you have 7. B, D is equal to 7. Okay, and you cut these lines from here. Done.
Then
Then
C,
what?
C. Then we will add
C
C.
and BD. C and BD. Okay. C and BD. Okay, so it gives you CBD gives you 13. Now cut C.
11, 11, 12.
11, 12. AE. A and D. Okay. So AE will give you 23. Done. Then CBD.
AE will be separate, na? Like, what will be the level of AE?
This one.
What will be the level of AE?
I am just using AE. You can use whatever you want. I am just using AE.
No. I am asking what will be the level. Will it be with the C or will it be with the BD?
Neither. It's another separate node. This is a separate node here that I am creating and I am adding AE to it. This node is labeled AE. This is nothing. This is a forest now. This is CBD. This is not a tree as of now. I haven't constructed the tree yet. These are just, this is a forest. This is one tree. This is another tree.
Okay. Then
Then I take CBD and AE. Right? These two will be merged.
Yes.
Okay, so this will become CBDAE or whatever. And this will be merged with F. Right?
Yes.
Okay, so now find the ABCDEF. So A is having 1, 2, 3. A is 3.
Okay, it's at level 3. Means like A is at level 3 then.
Yeah, 1, 2, 3. This will 1, 1, 0.
Makes sense. Yes. 110. And then
Okay?
B will be
It will be 1, 2, 3, 4.
this side will be 0, right? So this 1
Left
0
0.
1
Left
0
0.
1 0 1 0 1 0. 4 4
1,
4
0, 1, 0, 4.
4.
Okay? See, you just count the edges till there, no? From the root to the leaf. So C is 1, 2, 3. Got it? Why
Yes.
3? This is 1, 0, 0. So 3 digits.
Okay, makes sense. Makes sense.
Okay?
D will be again 4.
1, 2, 3, 4. Yes.
E will be 3.
Yes.
F will be 1.
Exactly. Okay? Totally.
Okay, I got my error. I was doing was I was taking AE as leaf. Means like
Oh.
the last that level was like 4. That's why I was giving the wrong answer.
Okay.
Got it. Yeah. That's all.
Okay. Anything else you want to discuss?
मैम मैंने एक लिंक शेयर किया है कि क्वेश्चन पेपर उस क्वेश्चन पेपर का आप कुछ क्वेश्चन सॉल्व कर सकते हैं, देखिए.
It's already 10:30. 10:15. Okay.
क्वेश्चन नंबर 10 से करिए आप एक बार. 10 तो ले मैक्सिमम लेटनेस है, आप 12 से करिए एक बार.
12
12
से करूं?
हाँ, और स्टेटमेंट में क्वेश्चन करना.
हाँ? Selected बोलो ना. Question number 12 क्या है? Let G be a complete undirected graph with 5 vertices and 10 edges. With weights this. What is the maximum possible weight of a minimum weight spanning tree G can have? बोलो क्या होगा?
Wait a minute मैम, 12 तो नहीं लगता है. हाँ 12 ये वाला.
बोलो क्या होगा?
थोड़ा सॉल्व करिए, थोड़ा कुछ स्टेटमेंट बेस्ड क्वेश्चन
देखो
करिए.
1 तो पक्का रहेगा, राइट? 1 तो पक्का रहेगा. तो we need maximum possible weight, so we will be wanting to have 2, right? So we have already covered 2 nodes with 1, A and
Then
B.
we have to avoid 3, I think, to avoid cycle.
Yeah. So we have covered 2. Let's say we are not covering 2. Okay. We will be covering 2. This is C and D. Okay, we had 1, we had 2. Now, out of these edges, which one will we be choosing? We have to choose the minimum one which is connected to E, right? And we have to connect one value to this, right? And that should be the maximum possible value. So, can we skip 3? If 3 is connected between these two, or 3 is connected between these two, or 3 is connected between these two, we will have to choose 3.
Oh, 5 vertices, and yeah. Then we can.
Right? So we will need to choose 3 no matter what. Okay? So we will have to choose 3. So 1 plus 2 plus 3. Then what? Can we ignore 4? 4 can be ignored, right? We can have from here to here, or from here to here, or from here to here. Okay? So only one more vertex you have to connect to this tree that you have already gotten, right? And what I'm going to assume is this particular vertex is connected by the maximum edges, that is 9 and 10. Okay? So if the vertex is connected with 9 and 10, then the only way you can you will be adding 9 only, right? So you will be adding 9 here. Then what is the answer? 15. Is this the answer?
हो सकता है, मुझे नहीं पता.
Okay, मुझे भी नहीं पता.
14.
14.
आप आंसर डाल के देखिए एक बार. अब लर्निंग मोड पे आइए, लर्निंग मोड कीजिए.
Okay, wait. कौन सा क्वेश्चन था?
12.
14 दे रहा है,
Hmm.
हमारा 15 कैसे आ गया? ओके, ये हुआ 1 2 3 4 5 6. ओके, ये इतने में तो 6 ही हो सकता है. ओके, 1 2 3 4 5 6. ओके, इसको कनेक्ट करने के लिए 1 मिनट, 5 ये है ना, 6. Yeah, so E can be maximum connected with a of length 7 here. तो ये 7 हो सकता है.
मैम तो कंफ्यूजिंग हो रहा है तो इस क्वेश्चन थोड़ा एक बार पहले से करिए ना.
हाँ कर रही हूँ, रुको पहले मैं तो देख लूँ क्या हो रहा है. Okay, देखो we have A, B, C, D and E. Okay, let's say my AB is connected. We want to ignore, we have to compute the maximum possible weight. So we will ignore as many minimum possible values as it is possible. Okay, minimum values as possible. So we start with 1. We will have to take 1 no matter what. Okay, let's say 1 is connecting between A and B. We will have to take 1 no matter what. Let's say we will go to 2. Let's say B and D are connected with 2. Okay, then we will have to take B and D no matter what, right? So now there is the question of 3. Can we choose 3? That is the connection choice. The only way we will ignore 3 is if it has already been covered between these 3. Is there a way where you can cover 3 in these 3? No.
AD. If AD is forming 3.
Exactly. So AD we are putting 3 over here. Okay. Then 4. So 4 we will have to include. We cannot exclude. Okay. So 1 2. Then we have to include 4. So where will 4 be included? 4. Let's say we are saying C to D. Let's say we are saying it is 4. Okay. Now C can be connected to B or A or whatever. Okay. Now can we exclude 5? Is there a way to exclude 5?
हाँ, A to C connect करेंगे तो 5 exclude कर सकते हो.
Right. Then what about 6? Can we exclude 6?
No chance.
B to C.
Oh.
Okay. Then 7. The edge with 7 will be connected to E because there is no other way to connect anything over here. Okay. So 7 has to be connected to E. Okay. So E will be connected to, let's say, A using 7. Okay. And 8, 9, 10 can come over to here or here or here. No matter where it goes, we will have to pick 7. Okay. So this is the final solution. 14. Okay.
ओह अच्छा, जैसे 7 आएगा आप आगे नहीं जाएंगे फिर.
Exactly, your minimum spanning tree is done.
1 2 4.
Ma'am, can you explain it again?
Okay. See, the idea is you want a maximum weight, minimum spanning tree, maximum possible weight, right? So the thing is, what we are going to do is we will try to exclude the smaller values as much as possible. If we can take the maximum values, then we will get a maximum value. But that is not allowed because it is a minimum spanning tree. So we will try to exclude as many smaller values as possible. So we start with 1. Okay, the edge with 1 weight. We have to include that, right? Because we cannot ignore that no matter what. So I will be including the edge weight with weight 1 in my minimum spanning tree. Okay, then the edge weight with minimum weight 2. Edge with weight 2. Can I exclude it? Is there a way to exclude it? Can I put an edge anywhere in this graph so that I will not take 2 in the edge with weight 2 in my minimum spanning tree? Is it possible? No, because wherever you put it, your 2 will be connecting a new node. Okay, it will either connect, but you can put between B or C, you can put with BD or AC or CD, no matter what you connect, wherever you put, you will be connecting to one new node. So that is why I will have to take this edge with weight 2 in my minimum spanning tree. Okay, now if you go to 3, now is there anywhere I can put this 3 edge so that I cannot have 3? I will not pick the edge with weight 3. How do you do that? You put the edge between A, D. Okay, so this will give us a weight of 3. Okay,
मैं व्हाट्स द कॉन्सेप्ट, हमें छोटे वैल्यू को इग्नोर करना है।
छोटे वैल्यू को इग्नोर कर रहे हैं क्योंकि हमें मैक्सिमम पॉसिबल वेट चाहिए। हमें एक ऐसा ग्राफ बनाना है जिससे अगर हम मिनिमम वेट स्पैनिंग ट्री निकालते हैं देन इट विल हैव द मैक्सिमम पॉसिबल वैल्यू। So that is why we are wanting to ignore this 3 so that we will have the minimum weight spanning tree of this resulting graph will be the maximum. समझे? You get it?
यस मैम, समझो।
Okay. So this is how you solve it. You want me to continue?
यस मैम, कंटिन्यू कीजिए।
Okay. So 3 you added here. So I will be ignoring 3. I don't need 3 anymore. Now what about 4? Is there any way you can put the edge 4 here that you can ignore it? No. So I put it, no matter wherever I will put the edge 4, I will be taking one new node into account. So I will put the edge 4 over here. So here my minimum spanning tree will connect to C. Okay. Now what about the edge with weight 5? I can put AC over here. Okay. So my edge with weight 5 will be ignored. Then edge with weight 6. For that I can put between BC and edge between BC and of weight 6, and now this will be ignored. Okay. Then we have weight 7. Is there any way I can put 7 edge with weight 7 so that it will be ignored? No, because the only possible way we can connect to nodes is to connect E with one of these edges. Sorry, one of the nodes. So E to A or E to B or E to C or E to D, whatever. I will the edge with the weight 7 must be connecting E. And E is not already there in the minimum spanning tree. So that's why I will be taking the edge with weight 7 and connect to E. Okay, you already got your minimum spanning tree, so now I have to stop now. Okay, so this is the maximum weight of the spanning tree possible. Got it? Got it? Okay, I'm assuming you got it. What else you want to discuss? What doubts do you have? What else doubt do you have?
Ma'am, next one.
Okay, जल्दी करो. भूख लगी है.
नेक्स्ट वन का फॉर्मूला क्या होगा? तो मैंने तो मिनिमम जो होता है
Minimum number of elements possible in a binary heap with a height of 9. Consider the height of the anti-binary heap is 0.
बाइनरी हीप नॉट बाइनरी ट्री मैम यहाँ पे इसलिए कंफ्यूजन हो रहा है.
देखो हाइट हमारा हीप का बाइनरी हीप है ना. तो
वैसे
यहाँ
मैम एक बात पूछे. आर यू फ्रॉम बंगाल?
नो.
ओह ओके.
But I can understand Bengali. I'm not asking you to talk in Bengali because others will not be able to understand. Okay. So here, this is okay. In binary heap, what happens? You add a node, then the second node gets added over here. Third node gets added over here. Fourth node will be added over here. Fifth node will be added over here. Sixth node will be added over here. Seventh node will be added over here. You see the pattern? Then you are adding over here. Then you are adding over here. This is the structure of a binary heap, right? It's always a complete. It's always a complete tree. So the only way it will go to a height of 9 is if all the at the level 8, every one of the possible nodes will be there. Okay. So level 1 we will be having one node. Level 2 we will be having two nodes. This is 2 to the power 1. This is 2 to the power 0. Okay. Level 3 we will be having four nodes. Okay. Level 4 we will be having 2 cube nodes. Level 5 we will have 2 to the power 4 nodes. Level 6 we will have 2 to the power 5 nodes. Level 7 we will have 2 to the power 6 nodes. Level 8 we will have 2 to the power 7 nodes. But now I am saying that there is the binary heap has a height of 9, which means that there is a node at the 9th level also, which means that this is the minimum number of elements you require, so there will be one node in the 9th level because you need minimum number of nodes. Okay, so that's why we are taking this one. So the total number of nodes in the tree will be equal to 2 power 0 plus 2 power 1 up to 2 to the power 7 plus 1. Solve it now. This is the formula. Got it?
अच्छा, तो फिर मतलब 2 पावर h माइनस 1 होगा.
Yeah, 2 power h minus 1, 2 to the power h minus 1 minus 1 divided by 2 minus 1 plus 1. This is equal to 2 to the power h minus 1. Yep.
Ma'am, one thing here, you are saying binary heap of height 9, right? But the level that we are going is still 7. So it's like I'm not getting why.
See, this is because here we are having at the level 1 we are having one node. Okay, so that level 1 node comes from 2 to the power 0.
Okay, yes, makes sense. Huh?
Okay, at the level 2 you are having two nodes. This is just a numbering system. If I would have made this as height 0, no, if this would have been height 0, then it would have become 0 and so on. Okay, so at this level 1 you are having this two nodes, so that is 2 to the power 1. Okay, at level 2 we are having four nodes, which is 2 to the power 2. This is level number 3, height number 3. Okay, this is height is 2, this is height is 1. Okay, so that is why at height number 8 we are having 2 to the power 7 nodes.
Okay.
So
and ninth node will only have a single value.
Yeah, ninth node will have a single element. Ninth level, ninth height number 9 will have one element.
Okay, and there was another theorem, right? There was some height is equal to n minus 1 plus n minus 2 plus 1. So that was something regarding minimum only, but it was not for binary, right?
हाँ, मैंने भी उससे किया था, तो 88 है मेरा आंसर.
But the answer is 215 something. Okay, so this is something different. Okay, this is something new.
ये क्वेश्चन पेपर अच्छा है.
I have to solve it.
मैं सॉल्व भी कर रहा था इसको अभी.
Okay.
मैम 15-16 मैम.
हाँ कर रही हूँ. Which of the following statements is not true for heap sort? Seriously? Okay, complexity of heap sort is n log n irrespective of the sequence of elements. You tell no. What do you want me to solve here? Divya,
हम्म
what do you want me to solve here?
मतलब आप एक बार सॉल्व कर ही दीजिए, एक्सप्लेन कर
मैं नहीं
दीजिए.
करने वाली ये तो this is just theory. Just search
Theory,
online.
it's theory.
What is not theory here? Tell me. Complexity of heap sort is order of n squared in worst case and n log in best case. It's not theory. Just go to heap sort. कॉम्प्लेक्सिटी कैसे आ रहा है मैं अभी नहीं पढ़ाने वाली तुमको रात के 10:30 बजे.
Heap, so complexity of heap sort on square in worst case and on log in best case. लेकिन ये तो गलत आंसर दे रहे हैं यहाँ पे.
कौन दे रहा है? क्या गलत आंसर दे रहा है?
चेक करिए एक बार. चेक आंसर.
Okay. n log n irrespective of the sequence of elements. हाँ तो the complexity of heap sort. Complexity of heap sort is n log n for its best case, worst case, average case.
Average case, every case has this n log n only. It's like
Yeah.
log n is coming from the this binary
Height
thing
of
that
the
we-
tree.
height of the tree. So
Yeah.
n is just the amount of work done apart from that. So
Okay. So that's why it is n log n.
I think every case has this, right? Means for any case,
Yes.
this will be
Yes.
n log n only.
Yes. See. Said. I got the wrong one. See, it's there in the index here itself. Delete max is n log n. Building a heap is order of n. In place sorting is n log n. This is for what problem? Heap sorting. Okay, heap sorting. Why this one open?
मैम तो आखिरी में 17 कर देना. 16 तो इजी है.
16 easy है. Okay.
हाँ 16 से
17 I also wanted to.
Let coins be a list of k coin denominations that are available in as much quantity as you want. You want to pay a sum of x rupees using a few coins as possible from the coin denominations given in the list of coins. Okay, using the following greedy strategy. Consider the following greedy strategy. Sort the coin denominations in descending order and then repeatedly choose the largest coin denomination that is less than or equal to the remaining amount. Subtract the chosen coin value from x and continue this process until x becomes 0. Which of the following is there are counter examples that prove that a given greedy strategy is not optimal? This is a really good question. Okay. So what is happening here is, this is something different than the other problems that you have solved. What is given here is you are given the greedy strategy. This is an algorithm that is given to you to solve this problem. Okay, and you have to tell which of these particular, when you apply the algorithms on these algorithms, these input values, which of them doesn't give you the correct answer, the optimal solution. Okay, so here the problem is what we are having k coin denominations. Let's take the first option. Okay, I'll take the second option. Okay, we are having 10, 1, 2 and 5. So we are having 10 rupee coins, 1 rupee coins, 2 rupee coins and 5 rupee coins. Okay. Now we have to pay somebody with 25 rupees coins, but you can choose as many little as possible. Okay, and all of these are available in bunches. You are a bank. Okay, you have to pay somebody with 25 rupees. So how will you pay that 25 rupees? You have to choose a minimum number of coins. What will you do here? Which values will you choose in generally? You will take
2 10 and 1 5.
Sorry?
2 10 rupees and 1 5 rupees.
Exactly. 2 10 rupees and 1 5 rupees. The 2 10 rupees will give you 20. 1 5 rupees will give you 5. You get 25 rupees, right? So now this is your optimal answer. So what this greedy strategy will do, let's apply the greedy strategy to this particular scenario. What happens? We sort the coin denominations in descending order. We do 10, then 5, then 2, then 1, sorted. And then we repeatedly choose the largest coin denomination that is less than or equal to the remaining amount x. So what is x? 25, largest coin which is less than equals to 10 is less than 25, so I can take a 10. Okay, so I took one. First coin is from 10. Then what is remaining out of 25? 15 is remaining. So what is the largest denomination less than 15? 10. So 10 I can take. The second coin that I will choose will be a 10 rupee coin. Okay, and I will subtract 10 from here. I get 5. Okay, then I choose 5. The largest denomination less than equals to 5 is 5. So I take a 5 rupee coin, and that is the third coin that I'm choosing, which is, so you are done with 3 coins. Okay, so the number of coins that you need is equal to the 3, is equal to 3 here. Here also it was in the optimal strategy that you know, it was 3, and here also it is 3. Okay, so this is not a counter example. Okay, you have to solve each of these likewise to find a counter example. Okay, we'll find which of these will give you the counter example. Okay, if you want to know how to find this optimum value, you can either use your normal logic that you use for finding the finding the optimum value, or there is a coin denomination problem. There is an algorithm, DP algorithm, for the coin denomination problem. I think you must have solved it in your uh, live sessions. Must have been discussed, right?
In the late code.
Sorry?
In the late code session, this question was discussed.
Yeah, to find the DP algorithm to find the optimal number of coins to solve this coin denomination problem.
No, DP means dynamic programming.
Yes, DP means dynamic programming.
So, which has been covered yet?
Dynamic programming hasn't been covered?
No, Week-9 hasn't been covered.
No, ma'am.
और वो तो सिलेबस में भी नहीं है. Week-5 to 8 है. Week-9 में है dynamic programming.
Ma'am, there is one more problem in this paper, which has similar type of flow, right? There they have given some story, and then we have to sort according to that. It's not solve according to that. Let me just find that.
Which one?
Let me just find that.
हाँ भाई, ये तो बहुत दिक्कत हो रहा है, क्योंकि ऐसा होगा तो मुश्किल है थोड़ा.
नहीं, ऐसा नहीं होगा. एग्जाम में अगर ऐसा हो रहा है तो मार्क्स मिलेगा. अगर प्रॉब्लम आ रहा है तो तुम्हें मार्क्स मिलेगा. उसका टेंशन करने की जरूरत नहीं. ओके, इसमें और क्या डाउट है बताओ.
No, ma'am, it is not in this one. There was one question where you need to find means that the way to get to a particular number was given, and you need to find the way to get a nth number using the least amount of digits possible. Something like that was there. Like you can just either add 1 to it or divide it by 2. That was something related to that.
That is a very hard question. That is covered in advanced data structures.
I don't know why, but they had given that question. So the way was that for even number, you divide by 2, and for odd number, you will just subtract 1, and then make it even, and then again divide it by 2. Until then, you will get once you get at the level 0, means like the answer will be 0. That will be your solution. Means number of steps, or means those digits which you are dividing and getting after doing all this calculation.
That is a dynamic programming.
I know, but that was a question. I don't remember which paper it was, but there was a question. I have solved that.
See, you will not be getting dynamic programming solutions, questions on dynamic programming in the exam. Okay, if you are
Was
getting
there any syllabus change, ma'am, recently?
Sorry?
Was there any
Sorry?
syllabus change recently?
No,
Syllabus change. I think syllabus was changed.
I
Like
have no
before,
idea. I have no idea. Okay. Regarding
Even
the syllabus change.
PDSA. Week 1 to 8. See,
week 1 to 8.
copy,
Week 1.
paste. Wait, copy, paste.
Okay, any more doubts you have?
I don't have, man. I think that's more than enough. Like we had done a lot of questions today.
Sorry?
Hmm.
We had
No,
done
no,
a lot of
you have
questions,
done a
so
lot of
it's
questions.
okay. It's okay, miss. All doubts are
हम्म
clear.
और 10:30 भी बज चुके हैं 10:30 सुबह 10 बज
10:40 बज चुके
हाँ
हैं.
हाँ
I
10:40
think your time was till 10, right?
The time was, I don't know what the time was.
Okay.
All I know is I'm hungry. Okay.
Okay,
yes I
okay. Sorry for this.
No, actually, it's not your fault. I am like heavily sleep deprived and hungry. Okay, I had a deadline. Okay, I'm stopping the presentation, the live
streaming
session. Okay.
हम्म
Okay, ma'am. Thank you.
Yeah, I haven't actually slept in over 36 hours, so that's why I'm like.
36 hours
Yeah.
wow means you are doing something projects or
Not project. I had a paper submission deadline today.